Hi, today we are going to look at the probability. First, we will look at the simple examples of probability. We will clear simple concepts and simple terms. Then we will move on to the complex concepts and the complex terms of probability. Let us look at the definition of probability. The probability is said to be the branch of mathematics which concerns with the numerical description of how likely an event is occur. We will look at what is event and what is this occurrence of an event. We will come to this definition afterwards. First, let us look at the examples. A person Rahul is there. He plays a lot of dice game and he found out that a- any of the number which are given on the dice are coming. Maybe 6 comes, 5 come, 3 come, whatever we thinks, maybe that will come and that will not become. But he is interested in the mathematics, that how all these events are occurring, means all these numbers are coming. One, why 5 is coming, 6 is coming, and what is the possibility that 6 will come out. So is there any way that I will win the dice game every time? So Rahul is that kind of person. Now, to understand this, Rahul went to a mathematician and described his problem to his mathematician and asked, "Sir, please help me because I want to win the dice game every time." But mathematician said, it is not possible because this is all based upon the probability and the possibility of the events which you are talking about. But we cannot decide what is going to come, but we can uh, uh, we can give a possibility, we can give a mathematical term to that, we can give a mathematical numerical value to that, we can find out the values, but we cannot decide that what is going to come. But Rahul was really interested, and Rahul said that sir, I want to know about mathematics. Sir said that there are many scientists like J. Cardan, Simon Laplace, James Bernoulli, D. Markov, A. I. Kalali. These are all the scientists who have worked in this field, and they have defined the probability, they have defined how events occur, how things are being done in your dice game, in all the games which we play, and lot of things are there. But Rahul wants to know more. Then the professor said that okay, that you come to the class, we will be looking at the probability in its mathematical terms, we will be learning the probability. So you may not be able to win the match, but you will be able to give a kind of possibility, a kind of you will be able to calculate that what are the things which are going on. So he said, all right sir, we are coming in the class. Now our class starts. First, we are going to look at the two simple terminology of probability, that is fair and unfair. Fair means something which is natural. If you roll a dice, then what are the numbers which are possible which will occur on the dice? 1, 2, 3, 4, 5, 6. These six terms can come. But if in the dice only one is coming, means in all the direction one number is given, then it is called unfair because that is unnatural. Every time one cannot come. Similarly, you can look at here coin. How the coin is fair? The coin is fair if one side there is head and on another side there is tail. But if both the side you have uh, just like in a Sholay movie, In both the side there were had there was had. So on the basis of that, every time you will win the match. If you toss a coin, you every time win the toss, because on each side head is given, there is no tail. So that is called unnatural, that is unfair. There are two ways by which we can solve our probability: experimental approach and empirical approach. We will be looking at these terms later. There are three types of probability: classical, axiomatic, and statistics probability. We are going to look at classical probability in this video. What is an experiment? An experiment is a procedure that can be infinitely repeated and has a well-defined set of possible outcomes. If you roll a dice, there are a lot of sample space. There is a sample space in which a lot of values can be come, like 1, 2, 3, 4, 5, 6. There are 6 values which can come in the sample space of a rolling of a die. This is called a sample space, and while we are performing this this while we are rolling the dice, we call that experiment again and again, because again and again we are getting an output. We are getting 1, we may be getting 2, we may be getting 3, 4, 5, 6. So this is an this can be done infinite times. You can infinitely roll a dice, you can infinitely toss a coin. So that is what we are calling as experiment. And this is the sample space of an experiment, means all possible outcomes, set of all possible outcomes, that is denoted by S. What is a random experiment? An experiment is said to be random if it has more than one possible outcome, and deterministic if it has only ones. A variable which stores all the possible outcome is known as random variable. Like you can see, there are two types of sample space: finite sample space and infinite sample space. If you are saying if you are rolling a dice, that is finite sample space. But if you are saying that I will roll the dice till 3 comes, then that may take a infinite number of, sample space. You cannot define that. That may take a infinite number of trials, events. Combination event is a combination of outcomes, or that is a subset of sample space. For example, if we rolls a dice and uh, define an event, then there can be two event. We have defined two events: event E1 and event E2. Event E1 is telling about the occurrence of even number, while event E2 is talking about the occurrence of odd number. There are two types of events, which are impossible events and sure events. First, we look at the event in detail. What is an event? If you are tossing a coin, then there are two elements, or there are two outcomes which can come, that is head or a tail. So there can be two events: either head will come or tail will come. So that is what we are calling as an event. Event means a subset of a sample space. If you are rolling a dice and you are saying I want even number in that, so the sample space is 1, 2, 3, 4, 5, 6, and the even number within that sample space would be 2, 4, and 6. So that is the set of 2, 4, and 6 is known as event, because that is a subset of sample space. If that was not subset, then how could that be an event? So event is a subset of sample space. Now, there are four types of events. Normally, if we look at impossible event, means an event which can never happen. Without aeroplane, you cannot fly, and that is the possibility is zero. I am just giving an example. If you are talking about flying jets, and a lot of technologies are coming with which you can also fly without aeroplane, but I am just given an example. Without anything you cannot fly, without any technological instrument or gadget, and without aeroplane you cannot fly. All right, so the probability is zero. Okay, and but you can run on the road. So the possibility of running on the road is one. You can surely run, you have legs, but uh, you don't have your wings to fly. And all the type of probability which we are looking at, that occurs between 0 and 1. Neither probability can go negative, nor it can go more than 1. That is the thing which we need to look at. Simple event. A simple event is an event which is containing only one sample point. For example, occurrence of even prime number in rolling a dice is 2. So the sample point of that event is only 1. That is the reason why we are calling that a simple event. Simple event means an event containing only one sample point. If you look at the even prime number in rolling a dice, then only one prime number is there which is even, that is 2. Alright. On contrary, compound events are there. If an event contains two or more sample space, we call it sample point, sorry, we call it compound event. For example, occurrence of odd number in rolling a dice, that is 1, 3 and 5, we call that compound event. According to the classical definition of probability, probability of event E is defined as the number of favorable outcomes upon total number of outcomes. But this definition is valid only if the outcome of an experiment are equally likely. You might be thinking that what is equally likely? Look at the term equally likely. If the probability of an occurrence of an event and non-occurrence of an event is equal, then they are said to be equally likely or equally probable, equiprobable. For example, occurrence of even number in rolling a dice. The probability of occurring of even number in rolling a dice is 1 by 3, while non-occurrence, the probability of non-occurrence is also 1 by 3. These are the even numbers, and that these are the odd numbers. The probability of even number as well as odd number are equal, both of their happening and their non-happening also. So that is the reason we are saying both are equally probable. In the above, happening of event E1 is 1 by 3. Then in above example, non-happening of E1 is also 1 by 3. The happening of E1 is 1 by 3, and the non-happening is also 1 by 3, because in sample space there are 6 elements. Out of 6 elements we are taking 3 elements in event, so the remaining elements are also 3, and the elements which we have taken in event, that is also 3. That is the reason why we are saying these are equally likely events. What is mutually exclusive? If the intersection of two events are null set, then those events are said to be mutually exclusive. In these both uh, event, event E1, that is 2, 4 and 6, and event E2, 1, 3 and 5. In both of the event there is no common element. Is there any common element? No, one is not there in event even, 3 is not there in event even, 5 is not there in event even. So we will say that is there is no common, there is no intersection. So the intersection of event e1 and e2 is 5, and the probability of intersection is 0. These are the elements, these are the events which are known as mutually exclusive. What are the exhaustive events? If we do the union of two events, then that union is equals to the sample space, and that event is known as exhaustive events. In above example, E1 and E2, E1 union E2 is equals to 1, that is sample space. What is E1? E1 is 2, 4 and 6. E2 is 1, 3 and 5. If you do the union, what is union? If you look at this union of event, this is event E1 and this is event E2. So if you add up both the events probability, that is known as union. Alright, so what is the definition of exhaustive event? The definition of exhaustive event said that union of two events is equals to the sample space. Similarly, here you can see if you add up both, if you mix up these both event, then it will be equal to the sample space. How? If you roll a dice, there are 6 possible outcomes which can come, out of which 3 are there, 3 are these. So if you add up or sum up these elements, you will be getting the sample space of rolling a dice. Easy. Uh, Now, so let us look at the complement of an event. What is the complement of an event? Suppose that we are doing an experiment. We are rolling a dice. In this experiment, 1 minute. In this experiment, you can see there is an occurrence of odd prime number, that is an event. Alright. So what is the sample space if you roll a dice 1, 2, 3, 4, 5, 6? What is the prime number? 2, 3 and 5, and odd prime number are 3 and 5. So if you understand uh, with it with the diagram, then the rest of all the element excluded 3 and 5 are called complement of an event. The rest part remaining rather than 3 comma 5, if you exclude 3 comma 5, then the rest of the part which you will get in this diagram, you will be calling that complement of an event, that is denoted by not e, complement of e, bar e. You can see the union of event and intersection of event. The union of an event E1 and E2 is defined by the mix-up of E1 and E2, the sum of E1 and E2. If you sum up the event E1 and event E2, that is known as union, and these are, that is event E1 and E2. These are the simple, this is a simple definition. If the common elements between E1 and E2 are known as are come in the set of an intersection. So now Rahul is getting bored and Rahul is saying that we will be seeing looking at the uh, another things in next class. That's all right, we will be looking at another things in next class.